part 2 of lecture 3 series that is focused on continuous integration, CI workflow, continuous delivery versus continuous deployment. So in the previous lecture, we understood the idea of DevOps and shift left testing. Let's move to one of the most important DevOps practices, that is continuous integration, commonly abbreviated as CI. The word integration is the most important word here, so let's understand what it really means. Imagine again that our software company is developing an online food delivery application. We have several developers working simultaneously. Notice something important. These developers are not working one after another. They are all modifying different parts of the same software at exactly the same time. Now imagine everyone works independently for 2 weeks. At the end of these 2 weeks, they all attempt to combine their changes into one project. This process of combining everyone's work is called integration. Unfortunately, if integration happens only after several days or weeks, many problems appear. Now developers spend days simply resolving merge conflicts and debugging integration issues. So continuous integration solves exactly this problem. Instead of waiting for weeks, developers integrate their work many times during the day. Whenever a developer completes a small feature or fixes a bug, they immediately commit and push that code to a shared repository such as GitHub or GitLab. But continuous integration is not simply about pushing code. This is one of the biggest misconceptions that beginners have. Many students think I pushed my code to GitHub, so I performed continuous integration. Not necessarily. Continuous integration only becomes meaningful when every code change is automatically verified. As soon as new code is committed, an automation server such as Jenkins immediately begins checking whether the software still works correctly. It compiles the application, it executes the automated test, it performs code quality analysis, it generates the reports. Only if everything succeeds is the software considered stable. Think of continuous integration as a quality checkpoint where that every code change must pass before becoming part of the main software project. Instead of allowing multiple problems to accumulate for weeks, CI detects issues within minutes. This immediate feedback dramatically reduces the debugging effort. Developers fix problems while they still remember what they changed. That is the real power of continuous integration. Now that we understand the idea behind continuous integration, let's see exactly what happens from the moment a developer pushes the code until Jenkins finishes verifying it. Whenever students first learn continuous integration, they often imagine Jenkins as some magical software that simply does everything. But automation always follows a sequence. Let's walk through that sequence carefully. We will continue using our food delivery application. Let's examine the first 3 steps of continuous integration. So step 1 is code commit. Everything begins when a developer finishes a small piece of work. Notice I said small. Modern DevOps encourages the developers to commit frequently rather than waiting until an entire feature is finished. Why? Because small commits are easier to understand, easier to review, and much easier to debug if something goes wrong. Suppose Sarah has successfully implemented the dark mode toggle. She commits only that feature instead of waiting until she has also completed several unrelated changes. She then pushes the commit to GitHub. At this point, GitHub becomes aware that the repository has changed. However, GitHub itself is not responsible for building or testing the application. Its responsibility is storing source code. Now something else happens. So the moment Jenkins detects that new code has been pushed, it automatically starts a predefined pipeline. Notice that no human clicks any build button. This is automation. Jenkins constantly monitors the repository. Whenever new changes appear, Jenkins immediately begins executing the pipeline. You can think of Jenkins like an extremely disciplined employee who never forgets to perform routine tasks. Instead of relying on developers to remember every step, Jenkins performs them automatically every single time. Step 3 is build the code. Now Jenkins downloads the latest version of the project, but the source code cannot be executed directly. It first needs to be transformed into an executable application. Exactly what happens depends on the programming language. If it is a Java application, Maven or Gradle compiles the project. If it is a Node.js application, NPM installs the dependencies and prepares the application. And if it is a .NET application, MS Build compiles the solution. The objective is always the same: convert the source code into a runnable software artifact. If compilation fails, Jenkins immediately stops the pipeline. There is no reason to continue testing the software that cannot even build successfully. The developer receives instant notification and corrects the issues before moving forward. Notice how quickly problems are detected. Instead of discovering compilation issues and failures several days later, developers know within minutes. This is another major advantage of continuous integration. Once the application has been built successfully, Jenkins must verify whether the software actually works. So this brings us to the next stage, that is automated testing. Building the application is only the beginning. Just because the software compiles successfully doesn't mean it works correctly. This is where the automated testing becomes essential. The first type of testing usually performed is unit testing. Unit tests verify individual pieces of code independently. For example, imagine our payment module contains a function that calculates the delivery charges. A unit test checks whether the calculation produces correct results under different conditions. Next comes the integration testing. Remember, software consists of many interacting components. The payment module communicates with databases, the login module communicates with authentication services, order tracking communicates with GPS services. Integration tests verify that these different components work correctly together. Some organizations also execute user interface tests. These tests automatically open the application, click the buttons, fill the forms, and verify whether the user interface behaves correctly. For example, Selenium could automatically enable dark mode and verify whether text remains readable throughout the application. Many organizations also include security scanning and static code analysis at this stage. The objective is to discover security vulnerabilities before the software reaches the customer. After testing finishes, Jenkins generates detailed report. These reports may include which test passed, which test failed, how much of the code was covered by testing, whether code quality standards were violated, how long the build required. All this information becomes available immediately. Finally, Jenkins sends the feedback to developers. If everything succeeds, the pipeline continues. If something fails, developers receive notification through email, Slack, or other collaboration tools. Notice the philosophy here. Problems are communicated immediately. Nobody waits until the end of the week. Immediate feedback leads to immediate correction. That keeps the entire software project stable. So far we have discussed the continuous integration concept, but after software has successfully passed all the tests, what happens next? This introduces another pair of terms that often confuses the students, that is continuous delivery and continuous deployment. In both approaches, developers continuously integrate their code, Jenkins builds the application, automated tests execute, reports are generated. So what is the difference? The difference appears only at the final stage. Let's begin with continuous delivery. Imagine our software company developing banking software. Every update passes through Jenkins successfully. However, before deploying to customer, the release manager reviews the build. Perhaps they verify the compliance requirement and they perform the final acceptance testing. The deployment occurs only after explicit approval. Notice that deployment is ready all at times, but a human decides when to release it. This is continuous delivery. Now consider another example. Suppose our company develops a weather application. Small improvements are released several times a day. Waiting for manual approval every few hours would become very inefficient, of course. Instead, once Jenkins confirms that every automated check has passed, the deployment begins immediately without waiting for human intervention. This is continuous deployment. So here's a simple way to remember the difference. Continuous delivery requires one final human approval before production, and continuous deployment removes the approval completely. Both approaches use automation. The only difference is whether a human presses the final deploy button or not. Many highly regulated industries such as banking and healthcare and aviation prefer continuous delivery because additional verification is required. Many internet companies with mature testing pipelines use continuous deployment to deliver the updates rapidly. So neither of these approach is universally better. The approach choice depends on business requirements, regulatory constraints, and the confidence in automated testing. Now let's have a short quiz. A company automatically builds, tests, and packages every code change. After approval from the release manager, the software is deployed to production. The key phrase here is after approval from the release manager. So the correct answer is continuous delivery. The software is always ready for deployment because it has already been built and tested automatically. However, a human decides when it goes to production. So the key phrase here is after approval from the release manager. So this is the defining characteristics of continuous delivery. If there were no approval step and deployment happened automatically, it would be continuous deployment. Every successful code commit passes all tests and is immediately released to customers without any human intervention. The important clue here is without any human involvement. So every successful change is automatically deployed to production after passing all automated tests. This is exactly what continuous deployment means. There is no manual approval or scheduled release. Next, a new feature passes compilation but fails integration test. Correct answer is stop the pipeline. Compilation only confirms that the code can be built. Integration tests verify whether different components work together correctly. Since these tests failed, Jenkins or any CI/CD tool should immediately stop the pipeline. Deploying software with failed tests could introduce serious defects in production. A bank requires a manager to approve every production release due to compliance regulations. So this is continuous delivery. Banks operate in highly regulated environments where every release must be reviewed and approved. Continuous delivery supports this requirement because deployment are prepared automatically but still require a manual approval after reaching a production. A developer fixes a critical production bug. Pipeline builds, tests, and deploys automatically within 10 minutes. The correct answer is faster recovery from issues. The biggest advantage here is speed. Automated pipelines reduce the time required to fix production issues. Instead of waiting hours or days for manual deployment, the corrected version reaches the users within minutes, reducing the downtime and customer impact. A startup wants users to receive new features immediately after testing. A bank prefers manual approval before every release. Correct option is B. Startup to continuous deployment and bank leads to continuous delivery. So startups usually prioritize the rapid innovation, so automatic deployment helps them to deliver the features quickly. Banks prioritize security, compliance, and risk management, so making manual approval is very essential. Which company would benefit the most from continuous deployment? Answer is C. Social media platform releasing small features daily. Social media platforms frequently release small updates, bug fixes, and UI improvements. So automatic deployment allows users to receive these updates immediately. Now that we have understood CI/CD and deployment, let's introduce one of the most widely used automation tools that makes all of this possible. That is Jenkins. So in the next part, we will cover what Jenkins is, a detailed explanation of why Jenkins becomes so popular. Then we will review the Jenkins architecture. We will learn how to build jobs, what are pipelines, plugins, repositories, users, web UI, and how all components work together in one CI/CD ecosystem.